In this short video, I'm going to help you understand the basic concepts of electricity so the topic becomes a heck of a lot easier. As always, let's take something complicated and break it down into a set of simple ideas. We can use this to see how charge, current and potential difference all interact and affect each other. I'll also include some links to some useful practice questions in the description, so make sure you check those out. At the end, I'll tell you how you know that you understand the electricity basics. I'm going to start off with the electron. Here's one. It's a fundamental particle with a negative charge. Its charge is actually minus 1.6 times 10 to the minus 19 coulombs. Charge is just a physical property of matter, just like mass. Mass is a useful property that tells us how an object interacts with other masses. But what actually is mass? Well, our best explanation is probably it's the amount of stuff in something. Charge is a useful property that helps us explain how objects interact with other objects with charge. Charge is just the amount of electrical stuff in something. We give charge the symbol Q and the unit the coulomb. It's Q because many years ago it used to be called the electrical quantity. Now an electron that's sat there has charge, but it's of little use to us. We need to give it energy. To give an electron energy, we use a cell or a power supply. These supply a voltage or potential difference, which are pretty much the same thing. The voltage is simply the amount of energy given or taken away from each charge. 1 volt is just 1 joule of energy given to each coulomb of charge. Giving these electrons energy means that they can now move and pass their energy on to other components in a circuit. You may see that some components have a supply voltage. A lamp, for example, could be a 12-volt lamp. That means for every coulomb that flows through the lamp, that coulomb of charge has to supply 12 joules of energy. 12 volts is just 12 joules per coulomb. You've probably realised by now that the equation for voltage or potential difference is just V equals E over Q, where V is the potential difference in volts, E is the energy in joules, and Q is the charge in coulombs. I would prefer to write this as V equals delta W over Q. That's because it's actually the change in energy or the work done for each unit of charge. The potential difference is measured between 2 points. It's the amount of work done on or work done by that each charge as it goes between those 2 points. That is why voltmeters must be connected in parallel. If we have charges flowing around a circuit, then we have a current. You'll hear some refer to current as the flow of charge. That is not right. There's an important component missing, and that component is time. Current is the rate of flow of charge. Inserting the word rate tells us we are talking about an amount in a given time. We could say that current is the amount of charge flowing past a point per second. The symbol that we use for current is I, and the reason for that is that it used to be called the electrical intensity. We could therefore say that I is Q over T, where I is the current in amps, Q is the charge in coulombs, and T is the time in seconds. I would personally write I is delta Q over delta T as a better representation of the rate of flow of charge. The current is measured at 1 point in the circuit, and that's why we connect an ammeter at series at that point. Before I give you my tip to check your understanding of the basics of electricity, please do take a moment to like and subscribe if you found this useful. I also welcome comments, and remember there'll be a link in the description to some practice questions and other resources. So how do you know that you've got a good understanding of the concepts? Well, you can write down the equations just from your understanding without having to learn them. What I mean by that is that if you know the voltage is the work done per unit charge, then V must be delta W over Q. If you know that current is the rate of flow of charge, then it must be that I is delta Q over delta T. Test yourself by trying to explain this to somebody else.